Everybody, it's Eugene Liscio here, and welcome to Click 3D. This is the program where we talk about photogrammetry and how you can use your digital camera to create 3D models. Now, a lot of what I've been doing lately with the channel and with a lot of the different webinars is talking about photogrammetry and working with different photogrammetry packages. But we've also covered some topics on computer vision and similar things. So today what I thought I would do is also cover another method of reconstructing 3D surfaces using something called depth from focus or depth from defocus. And if you're a photographer and you know what image stacking is or focus stacking, then this will be somewhat familiar to you. But if you're not, it's a pretty clever way of reconstructing 3D models, and it's useful in a number of different areas. So that's what we're going to be talking about today: depth from focus, depth from defocus, and then later on I will give you an example. So let's get to it, and I'll go to my first slide here. So many of you know what depth of field is. So if you are a photographer and you do it for artistic purposes or whatever, depth of field is your friend because you use it as an artistic effect. But basically what it is, it has to do with the lens. And when you're focusing on an object, usually there is a range that is in focus, and then there's a range that's out of focus. So many times you'll see like a portrait photo and the person's face or whatever is nice in focus, all crisp and clear, but then the background is all blurred. You know, people use it as a nice effect. And you even see them in like Zoom meetings now or online meetings. Their whole, background is sort of blurred, but the person is in focus. So that's pretty neat. And there's different ways to control the amount of blur or the depth of field, how much blurring that you actually have. And so what you can do in that case is adjust the aperture on the camera. When we're working with photogrammetry, right, we're not really concerned about artistic effect. We want to capture or reconstruct the model, the surface, whatever it is that object is that we want to reconstruct. So in that case, blurring is not helpful to us, right? So we don't want to have any blurring. So the aperture settings should be set very high. So you'll see in this image on the screen right now, the image on the left has a very low aperture. So the f-stop or the f value is at 3. And you can see there's a very, very narrow band which is in focus. You see that the foreground and the background are way out of focus, like super, super blurred. So that's not that helpful to us if we're trying to reconstruct here and we're trying to figure out, what these letters are and the background, all that sort of thing. Now over here on the right, what we've done is we've taken the f, the aperture, and we've cranked it up. Okay, and we've turned it up to f22 here. Now you can see that the depth or the range of blur is much, much greater. So we can see we're getting blurred on the edge here and on the edge here, like in the foreground and the background, but nothing like what we have on the left. And basically what you're controlling is the opening, okay, the opening or the iris, if you want to call it that, of the camera. And so a high F number means a very, very small opening, and a low F number means a very large opening. And so in that case, having a very, very wide opening means you get minimal depth of field, okay? So this is a very simple concept to remember. Now, there are issues related to having a high F number or having a very low F number. And one is that if you're letting more light in, well, your shutter speed can be faster, right? So if you have a very bright day or even a darker day, let's say, and you open up and you allow for more light in, then it's no problem. You can get good shutter speeds, 200th of a second, 250, 150, something like that. And that's something you can do just by holding the camera in your hand. If you crank up the F number and you make a very, very small opening and you're restricting the amount of light that comes in, then all of a sudden on a dark day or something like that, you're going to have a problem with light. You have to increase the shutter speed. So now you're talking about, a second, 1/60th of a second, 1/30th of a second, something like that. Those types of shutter speeds are not great for holding a camera by hand. These are the kinds of things that you have to keep in mind when you're working with, especially on very, very small objects that have where you have a very narrow band or very narrow depth of field. You often have to use a tripod with a very long exposure. Now, typically how this works, and just a little illustration that I made here. And let me see if I can slide this over a little bit. Okay, there's the camera. Let me slide that over. So let's imagine that we have a lens. okay, and the aperture is wide open. So basically, I'm not restricting anything on this lens. I'm accepting light from the full range of this lens, okay, the full diameter from edge to edge, no problem. And then I've got a sensor back here. So basically, the lens and sensor combination is going to be the camera. And then what I'm going to do is I have an object. Let's say it's the apple, and I want to take a picture of this apple. Well, I know that the lens is a focusing instrument, and so it's going to take the light that's coming in and it's going to focus this at a certain point, right? Like on the sensor. And out here, there's going to be a range where, let's say we call it the best focal plane. There's a point where everything's going to be crisp in that plane, okay? A certain distance away from the camera lens, I'm going to have an image that's really, really crisp. And somewhere closer to the lens and somewhere farther away from the lens, I'm going to have a minimum and maximum depth of field. And basically once I cross that threshold, okay, so once I get inside of this area or once I get outside to farther away in this area, my image, my apple is going to be blurred, okay? And that's the basic premise here. Now, in terms of what happens when we change the aperture, open or closed, I kind of imagine it this way, and this is sort of a simple way of looking at it. But if you go back here and you imagine the, well, let me go back here. If I look at the minimum plane here, let's say, or this edge where I said, okay, if I intersect these lines, you see how big this area here is, right? So the wider that these are, the faster this is going to go out of focus, okay? So if you look at the area here, and then what I do is on the lens, I'm going to minimize, I'm going to restrict, I'm going to close that iris, okay, the aperture, and then I restrict the amount of light. So now I'm only leaving this little window open for light to travel through. So the only light that can come through here, okay, is like this. And so you'll see that the amount of blurring here, let's say, is minimized. And so in order to get to the same point here, okay, I have to move much farther away here and much closer to the lens here. So I have a much wider range for my depth of field. All right, so if you were to compare it to the previous one and this one, it's much different. So in this one, I've actually kept it the same, but if you were to say what's the equivalent, it would be somewhere over here or somewhere over here. So this slide here would be or the minimum and maximum would be much, much greater here. So that's kind of what's happening when you are adjusting the aperture. Okay, so if we compare the two, there you go. You can see that, you know, one is much wider at this point, and one here, when you restrict the aperture, then all of a sudden, you know, you have less blurring here. So when we talk about focal stacks, or when we talk about depth from focus or depth from defocus, they're kind of doing the same thing, or at least the way that they typically work is the same, but the way that they calculate things is different. So when we talk about depth from focus, what we're doing here is we're trying to figure out where the object is best in focus in the image. And if I move the sensor or the camera a little bit closer, a little bit closer, a little bit closer, or a little bit farther away, farther away, farther away, I have a number of photographs here. So in the case where I'm using my apple, you know, I'll take a photo really close, then further back, further back, further back, and further back. And what it's going to determine is that, you know, let's say that the apple that's farthest away, it's out of focus, so there's nothing in focus. And then when you get closer, right, I get part of this in focus, and maybe the back of the apple is out of focus. And then here, you know, everything is in focus. When I get here, maybe the, you know, part of the edges of the apple near the back are kind of in focus but blurred, and then here it's really, really blurred. So when trying to look at what is in focus, okay, if you have 20 images or 15 images or whatever, right, you can determine how close or how far something is from you based on you know, which ones are most in focus. So that's the aim. That's what it's trying to do. Now, depth from defocus is kind of the same, but it works a little bit differently in that instead of looking at what is in focus, it looks at how much blurring there is. So in this case, for example, if I took my camera and I did the exact same thing, obviously this camera that's really close and or I should say the photograph that's really close and the photograph that's really far away, they're going to be completely blurred, right? But what it's going to try to do is determine how much is it blurred and in which direction, like if it's really close or really far away. And by doing that, the degree of blurring, it can determine how far it is from, let's say, this best focal plane. And so if you can figure out how far the lens is, right, you can, or from an object, well, it means that you know the distance of that particular pixel. And then you look for another pixel and you can figure it out there, and so forth and so on. Now, depth from focus has some limitations because it needs a lot of images. And so working with depth from defocus, although more images is okay, you can work with that, it can actually recover depth with less images, which is super helpful. If you are a photographer you may use this technique when you're photographing insects or flowers or things like that, things that are really small. And what you do is you create a focal stack, or sometimes people call it focus stacking or whatever. And so basically you take the camera, you take a picture, you move a bit closer, take a picture, and then keep doing that, but in very, very fine increments, right? You want to sort of sweep this focal plane slowly across an image by moving the lens and the sensor closer or farther away. And that's kind of what you're doing. And this is an example. So this is a stack of images here. This is a cast of a finger. And you'll see here, this part here is really in focus, and back here, it's not in focus so much. And then what I do is I move closer, closer, and closer, and you'll see that the blurring changes. Where it's blurred on this series of images is slightly different. Now you'll also notice that the scale is changing slightly. Obviously, if I'm moving farther away or closer, then I've got some kind of a problem because it's changing the scale a little bit. And so in that case, the focus stacking algorithms take that into consideration. They can figure that out, and they can combine these images into one image, which is super crisp and clear. And that's what a lot of people do just from an artistic standpoint. They'll take a flower, an insect, they take this focus stack, and then what they do is they put it together to create one crisp image with everything in focus. And there's software and even hardware that will help you do that. So let me switch to a little website here, and I think this might be interesting to some of you here. Oops, let me switch over here. There we go. Here what we have is, let me just go like that, is something called StackShot. And so this is a little device where you can put your camera on, and what happens here is you have a controller, and this controller, you can basically adjust the increments that you take a photograph of a particular object. So that's kind of cool because you can set it up, put this on a tripod, get it set up for the first shot, and then kind of progressively take 20 or 15 or 30 shots or whatever, and you can know what the increment is as well. So that's kind of an interesting device that helps with that sort of thing. On the other hand, let me just see here. Let me get out of here. All right, there we go. There's software that can also do this. And so there's one that's called Helicon Soft. And so, I'm not getting any credit for this or whatever. I'm just showing you some things. This is an old program. It's been around a while, Helicon Focus. And let me just play this little video for you. So you'll see here that you have a number of images that are stacked. And you'll see that, you can see the grasshopper kind of getting smaller and smaller. And not only that, but, we take the image stack and you put it together. It does all the calculation for you. You can see everything is in focus, just like this. So this just on its own is just really attractive, something that a lot of people can have fun with, and photographing very, very small things. And if you're interested here, that's the link here, and I could even put it down afterwards into the text below. All right, so let's go back and talk about a couple other things, and then I want to give you an example. Okay, so, I talked about moving the camera, closer and closer, and then taking a series of images. But the other thing that you can do is leave the camera stationary and just rotate your focus ring. And if you rotate the focus ring incrementally, that kind of can do the same thing. But for most systems that use focal stacking or whatever, you're basically moving the camera. It's a very, very simple way to control, how much, and it's much easier with a controller to basically just move the camera by a known increment. So what I'm going to do now is I'm going to switch over and look at a microscope that we have here, and it's a Keon's microscope, and I'll talk about it when I get there, but it is using depth from defocus, and it's very, very useful for small items. So let me go over there and then I'll head back when I'm done. Okay, so we are at the microscope here, and this is a digital microscope from a company called Keon's. This model is the VHX 6000, but there's actually a newer model called the VHX 7000. They work similarly, but it's going to use depth from defocus in order to pick up some depth of a very, very small object. And this is not something that I would regularly do with a digital camera, but what I did was I just tore off a piece of paper, and if you can see that, what I did was I just wrote hello and okay. And what I want to do is recover some of the depth from the writing here. And I'm just going to do this rather quickly, and you know, for a tutorial kind of thing, or for a demo, hopefully it'll be okay. So I'm going to put this in here, and right now I'm kind of zoomed out, and what I want to do is I'll go into an area where I don't know, I've written something or it might be interesting, and then I'll create the depth. And the way that this is going to work is I zoom in, I go into the area that I want, and I focus on the lowest part, right, and actually go past that, and then I focus on the highest part, and in fact I go past that. So both the lowest part and the highest part will be out of focus, and what it's going to do is it's basically going to start well, you can tell it, but basically from the bottom, and it's going to go up and it's going to collect a series of images, and when it takes those images it's going to put them together. Now on top of that, what this thing will do is obviously when I have the lens and the sensor here, I'm sort of limited to a range of what I can see, but this can also stitch a larger image together. So I can take a piece of one and then connect it to another, connect it to another, connect it to another. So it kind of creates like this 3D mosaic, or this image stitching of a larger object or a larger surface, which is super helpful. So let's get to this and then see what it can do. And I should say we've used this on a number of different projects. Most recently, there was a project where we were looking at cut marks on bone, and in order to get there, it's obviously these are very, very small markings, and in order to sort of capture the whole area, we use this particular microscope. So it's great. It's a great tool for forensics and for looking at very, very small things like tool marks and cuts and things like that. Okay, so what I'm going to do is I'm sort of zoomed out. I'm at only 20 times magnification. So the first thing I'm going to do is I'm going to zoom in. Okay, and I have a little joystick here where I can kind of move around to the area that I want. So you can see I'm kind of moving here. Okay, so I'm going to move right here where the K is, sort of the center, and I can adjust the zoom just like this. Okay, so now that looks much, much better. And yeah, the area that I want is kind of this here, so sort of the straight line on the K, and then this part where you get this nice angle here, and we'll look at the pressure that we have from the pen here. So what I'm going to do is go to stitching, 3D stitching, and I'm just going to do a 2x2 image. So you can set it up so it'll take an image and then take a grid of 2x2 or 3x3. I'll just do 2x2. I think that might be big enough for now. And I'll say sure, go ahead. Now what I need to do is here, for example, it says set the upper range. So basically I have to take my microscope and go up, okay, up on the stage. And you can probably see this on the GoPro as I move this up and down, it's kind of wiggling around. So I'm gonna go, that's in focus, I'm gonna go up a bit, and that's way out of focus, so that's okay. So I'm gonna set my upper range. Then I gotta do the same thing. I'm gonna go down past the point where it's sort of all in focus, and then go down. And now one of the things I can do is if the magnification isn't enough, then I gotta bump it up. I gotta get into a higher magnification and stitch the image again. But this should be enough to just get us what we need. I've got that. The other thing too is I can adjust the image. So if I'm getting glare, if I'm getting some kind of issues from the object because the surface is causing reflections or glare, then I can try to accommodate for that based on the type of lighting that I have. And I can use HDR imaging and a number of different things to reduce that. So one of the things that you can't have happen here is if you have a very, very shiny surface, it's going to cause problems with reflections and things like that. And that's obviously going to affect the focus. So even when it's in focus, if it's kind of glared or overexposed or something like that, well, that's not good. So that won't help. But in this case, I think we have enough to get going here. Just leaving it on normal, it works pretty quick here. So I'm just going to go ahead. I just hit go ahead and stitch. And if you watch on the GoPro here, you should see the lens sort of moving up, and it's taking a number of images really quickly, and you'll see it stitching together here on the computer here, or on my screen. So once that's done, it's going to put everything together, and it looks like it did that. And I'm going to hit 3D display, so it's going to actually give me the depth from this. Okay, so here it is. I'm going to rotate there, so you'll see here, if I go back like this and I zoom in a bit. All right, so here you can see that I've got some depth that I've recovered, and that's pretty cool. So on this writing, you can see over here at this part, it went pretty deep. And let's look at this differently. Let's look at height and color. So you'll see some spots here that are darker. Okay, so it starts with the blue kind of at the bottom, and then the areas that get higher. So there's a really deep spot over here in this part of the K. And let me see if I can look at this. Let me see if I can exaggerate this. So right now I'm at 100% for the Z height, so I can exaggerate this a bit. I just want to make sure that you can see it. So yeah, you can see that if I exaggerate this back and forth, then this will work too. Okay. So I think that's all I want to show you on how this works and how depth from defocus can be useful. So if you have any questions or any comments, go ahead and put them down below, and I'll do my best to answer. But as you can see, very, very small objects. Take your camera, take a stack of images. You can process them in software like Helicon Focus, the same technique that's used here on a camera, on a microscope. Okay, that's all I have, and we'll see you next time on Click 3D. Thanks a lot, folks. Bye-bye.